Polyatomic ions. Okay, I know ion is like positive or negative. Polyatomic, I know what an atom is. It's a piece of an element. It's the smallest type of element you can get. A combination of protons, electrons, all that stuff. And then poly, I know from geometry, poly means many, like a polygon means many sides. Alright, so there are some covalent compounds. So covalent, I know that's share electrons. I know that means non-metals. So some covalent compounds that can only satisfy the octet rule, 8 valence electrons, by gaining or losing electrons becoming ions. Ooh, interesting. So they're not only sharing, they're also transferring electrons. These covalent compounds are called polyatomic ions. Poly means many, atomic means atom. I already said that. Therefore, these are ions that are made of many atoms. So ions, many atoms. Whereas most ions only consist of one atom. So for example, one common polyatomic ion is hydroxide, OH minus. Notice the minus right there. Oxygen has 6 valence electrons and hydrogen has 1. If the compound was just OH, there would only be 7 valence electrons, and there would be no way for oxygen and hydrogen to both get full valence shells. So you need another one. However, if another electron is added, there are now 8 electrons, octet, and both atoms can get a full valence shell. This extra electron adds an overall negative charge to the molecule, though, and so hydroxide is a polyatomic ion because it's a negative. Specifically, it's an anion. So look, the extra electron needed, right? This red one, right? The blue is what you would have if it were just O and H, but oxygen would be missing one, right? So you need an extra one. That gives it a -1 charge, like that. The name, charge, and formulas following very common polyatomics should be committed to memory. Alright, so that means you should study these. So you should be like, sulfate, what is that? I don't know. Whoa, it's SO4 2 minus. CO3 2 minus, what is that? Whoa, it's carbonate. Yeah, you should do that. Gotta study. Alright, so these three. There are like over 20. There are many polyatomic ions. You know, if you were to take AP chemistry, you would memorize almost all of them. Not all of them even, but almost. I'm only asking you to memorize 3. They're very common. When polyatomic ions are in ionic formulas, their name remains unchanged. So because these are ions, they can actually, form ionic compounds. They can, combine with metals or nonmetals to form anion, cation, attracting each other, crystal lattice, all that stuff. If there are multiple sets of polyatomic ions, they are enclosed with parentheses. So here, NH4 right, that would be actually 2 NH4s like that, and then 1 O. That would be ammonium oxide. So the first compound never changes, right? Usually it's a metal. Here it's actually ammonium oxide. This is interesting though, because you would think these are all nonmetals, it'd be covalent, but this is actually an ionic bond, because there's positive, and this must be 2 negative, right? Because this is plus, this is plus. This must be 2 negative to cancel that out, or else to have an overall charge. And then copper 1 phosphate. So this is actually 3 Cu pluses, and then 1 phosphate, which is PO4 3 minus. That's one of the ones you're supposed to remember. So notice the 1 means that it's copper 1 plus. So it's not phosphide. If it were phosphide, it would be like this. It would just be P, right? Because it's coming from phosphorus. It would be phosphide. But phosphate, it's a polyatomic ion. So you got to watch out for that. Watch out for that. Okie doke. See you in class.